Hi everyone, welcome back to Really Happy Chemistry Learning. In today's session, we will be discussing about postulates of VSEPR theory. Yes, the first rule is if the number of bond pair and the lone pair around the central atom is 2, 3, 4, 5, 6 and 7, you will be having the corresponding shape of the molecule as linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, pentagonal bipyramidal. Okay, as already we have discussed. And the next rule is the order of repulsion. Here the lone pair repulsion will be high and the lone pair bond pair repulsion will be lesser than the lone pair repulsion, and the bond pair will have the least repulsion between them comparing with lone pair and lone pair bond pair repulsion. Okay, for example, take CH4 NH3 H2O. This is the corresponding angles for this. For NH4 you will have 109 degree approximately, and for NH3 approximately 107, and for H2O approximately 105. Here you can see the number of lone pairs in the molecules. For CH4 is 0, for NH3 is 1, and H2O is 2. Okay, in H2O you have 2 lone pairs, so there will be the repulsion between lone pair and lone pair. Yes, so you can observe the lesser in the bond angle. Yes, and here you have only one lone pair, and for CH3 you have no lone pair. Okay, as you have 2 lone pairs, so the repulsion between lone pair and lone pair will lead to decrease the bond angle in H2O, while CH4 has ideal bond angle because it has no lone pair. Okay, yes, as you know, the structure is will be like this, right? CH4, and for H2O, yes, you have 2 lone pair you will be having, right? So due to this repulsion you have less angle compared to this CH4 because this is all are bond pairs. Okay, so this will be approximately 109, and here you will have approximately 105. Okay, yes, moving to the next rule. If the terminal atoms become more electronegativity than the central atom, these will pull the bonding electron towards itself. Okay, due to this it will decrease the bond pair repulsion, and hence that will decrease the bond angle. Okay, take this example, that is NH3 and NF3. So this will be the corresponding angles. For NH3 you will have 107 degree, while NF3 you have approximately 102 degree. So comparing these two, NH3 has the higher bond angle because NH, right? Okay, because NF3, here you can see fluorine is higher electronegativity atom, right? So this will decrease the bond pair repulsion and will decrease the bond angle. Okay, as usually you can see, right, for water we have observed, right, the repulsion between lone pair will be high and this angle will be less. Like that, for bond pair, further due to the high electronegativity, right? This, if you take this as fluorine, yes, NH3, okay, if you take this as fluorine, the electrons will be pulled towards fluorine, so this will reduce the angle between these. Okay, as the electron is pulled towards fluorine, it moves towards this and comes closer, right? This will come closer to the carbon atom, hence the angle between the fluorine and hydrogen will be less. Okay, yes. To make you more clear, I will take this example itself. Okay, if you take nitrogen and 3 hydrogen, and here nitrogen and 3, yes, this will be lone pair. Okay, so hydrogen, 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 here fluorine, fluorine, fluorine. As this is nitrogen is more electronegativity, the length will be more, right? But here, due to the higher electronegativity of fluorine, it will tend the electrons towards fluorine, so this length will be lesser. So here the angle will be more and here the angle will be less. Okay, I think now you will be clear with this concept. Yes, moving to the next rule. If you have multiple bond orbitals, they repel more than single bond orbitals. Yes, take this example, OF2 and OCl2. OF2 has approximately 103 degree and OCl2 has approximately 111 degree. Yes, the difference between these angles is because if you take this example, the oxygen is filled in 2p orbitals and in chlorine you have vacant 3d orbitals. So these p pi and d pi orbitals of oxygen and chlorine will overlap. That will leads to the CO double bond, and this will reduce the so this will increase the bond pair repulsion. Okay, hence the bond angle will also increases. Okay, so this is the concept. As you can see, when the multiple bond orbitals repel more than the single bond orbitals. Yes. Rule 5, order of bond angles. Yes, by applying the VSEPR theory, we will be characterizing the bond angle order. Okay, so that will depend on the valence shell configuration. Okay, if it is complete or incomplete valence shells, and then it also depends on size of the central atom, and then it depends on electronegativity of the atom and also the electron repulsion in the molecule. Okay, so these are the factors which will influence the bond angles. So while solving the questions, we will be discussing it in detail. Okay, so as for now, just take these points. Okay, and remember that while predicting the bond angle and while arranging, we should concentrate on these things. Okay, yes. As moving to the next topic, that is the hybridization of odd electron species. Also, while predicting the hybridization, generally we will select right what is the hybridization of the element. So if it is going to be odd electron species, there are two thing. When the central atom has higher electronegativity than the terminal atom, and the another case is terminal atom has the higher electronegativity than central atom. Okay, so first one, if the electronegativity of central atom is greater than the terminal atom, the odd electron is not counted in hybridization to find the hybridization. Okay, so take this example. As you can see here, carbon has higher electronegativity than hydrogen, right? So while counting the bond pair and lone pair, we will take only the bond pair. We will not add the odd electron. Okay, so this will be 3 plus 0. So 3 will correspond to the sp2 hybridization. Okay, so keep this in mind. If the electronegativity of the central atom is more than terminal atom, we will not count the odd electron. Moving to the next, if the electronegativity of central atom is less than the terminal atom, in this case you will add the odd electron pair in order to find out the hybridization. Okay, take this example. Yes, CF3. Here you will add both the bond pair and lone pair. So 3 plus 1, you have 4. So that will be corresponding to sp3 hybridization. Okay, so you can, here itself you can see the difference, right? If you have the difference in the electronegativity, and also that will lead to the difference in the count, right? And finally you will be having the hybridization difference. So one has sp2 and another one has sp3. So finally this will also lead to the change in the shape, right? Particularly if you have sp2 and sp3, we have the corresponding shapes, right? We have discussed in the previous class itself, right? So that will be, so this is so important, you should keep in mind while calculating the hybridization. Okay, yes, thank you. That's all for today's session. We will meet in the next session.